Hello everyone, Dr. Chen here. So we'll be discussing Newton's second law in this video. Newton's second law says the change of momentum of a body is proportional to the impulse impressed on the body and happens along the straight line on which that impulse is impressed. Okay, so the wording has been changed quite a lot since Newton wrote his book. So make it more understandable. So now if the mass of the object is a constant, this is a condition, if the mass of the object is constant, then Newton's second law says the net force on the object equals mass times acceleration. And we know force is a vector, acceleration is a vector, and net force should be in the same direction as acceleration. Force is proportional to acceleration times mass. Now from this equation we can also see acceleration is net force over m, and this is exactly how m is measured in the tendency of the object, the inertia of the object. Now let's assume apply a force m to a block with mass m, and we get acceleration 2 meter per second square. What's going to happen if we apply 2f? We double the force on the same object with mass m. What will be the acceleration? Go back to Newton's second law. Keep m fixed, double the force. What's going to happen to the acceleration? Double, right? So the acceleration is going to be doubling. Okay, now we keep F fixed. But we double the mass. We double the mass of the object. What's going to happen to the acceleration? Keep force fixed, double the mass, acceleration is going to be half compared to original acceleration. You apply F on m, I get 2 meter per second square. I apply F on 2m, I only get 1 meter per second square. Now if I apply 2F on m, I should get double the acceleration, which is 4 meter per second square. So acceleration directly proportional to the force, acceleration inversely proportional to the mass. This is Newton's second law, which is easy to understand. And now Newton's second law, this is in vector form. Now in algebra, a vector depends on what's the dimension we are interested in. In the space we live in, which is 3D, has 3 directions. Newton's second law actually tells us net force in x direction equals m times ax, net force in y direction equals m times ay, net force in z direction equals m times az, acceleration in z direction. Now, from the equation F equals m times a, and we give force, its unit is 1 Newton. In SI unit, F, the unit of S has to equal to the unit of m times a, and the unit of acceleration is meter per second square. Unit for mass is kilogram. So 1 Newton should equals to 1 kilogram meter per second square. And we have to do free body diagram to solve problem involve Newton's first law and the second law. Now what is a free body diagram? We have the object and we draw all the forces on the object. The object is represented by this dot, and we draw all the forces. We have to make sure the direction of the forces are correct, and this is called free body diagram. And then we can calculate what is the net force acting on the object. So in this case, I have a 275 Newton pointing to the positive x, 395 pointing to the positive x. Then we have a 560 Newton force pointing to the negative x. So the net force is a sum of all the three forces as vectors. 275 plus 395 subtract 560. The net force is 110 Newton. And after we find out the net force, we can calculate what is acceleration, right? Acceleration would be just the net force divided by the mass of the car. This acceleration. So acceleration is net force, which is 110 Newton divided by the mass of the car. So for example, if the car has a mass 1,850 kilograms, then the acceleration is 0.059 meters per second square.